So now, for this problem, it's kind of complicated, but it's also not too bad. So here we have, again, if there's acceleration, there's going to be all the sum of the forces equals the mass times the acceleration. And based on the calculation that b squared equals the radius times the gravity, we have that velocity equals the square root of 5. Okay, so moving forward, to find the forces in the y direction is 5. It's that initial velocity plus the initial velocity in the y direction plus 1/2 of at squared. So the reason why we have a 5.6 here is because it's the height plus the radius. And we just simplified it, so we get 5.6 instead of being 560 plus 0t, since the starting point is 0, minus 5t squared, since we know that here the acceleration is 10 divided by 2 is negative 5t squared. So then the x equals xo plus voxt. So since we already know that our v is square root of 5, we have square root of 5 times t, and our xo again is 0. So we start plugging in numbers here. So we have 5.6 minus 5t squared. We solve for t, and t equals 1.06. So now we put that 1.06 in terms of x. We have square root of 5 times 1.06 equals 2.37. So now remember, since we simplified that 560 to be 5.6, we have to add in that same 100 again to make the values accurate. So we do 2.37 times 100, which equals 237, which is approximately 240 centimeters.